Homework 2.6, Combinations of Functions, Video 3. Homework due on Friday, May 22nd, 2020 at 11:59 p.m. The next two videos center around questions 9, 10, and 11 on Homework 2.6. You might be thinking, oh, it's only 3 questions. Well, yes, but unlike the first 8 questions, which ask you one answer, what's the domain, each of these questions ask you not 1, not 2, but 8 things. Don't panic, they're not that bad. All right, so we're moving into the realm of combining functions, which is what this section is about. It's about the combination of functions. And there are 5 ways in which I'm going to show you to combine functions. This in the next video will show you the first 4. They're fairly intuitive: adding, subtracting, multiplying, and dividing. So let's take a look at this example and then we'll complete these definitions behind me. Suppose f of x equals x plus 1 and g of x equals x squared minus 9. Find the following functions and their domains: a, b, c, and d. F plus g of x, f minus g of x, f times g of x, f divided by g of x. Now, the definitions of these are so intuitive, I could probably just not show them to you and we would be okay. What do you think it means to find the sum of 2 functions? Well, the answer is you take the 2 functions and you add them. So yes, to find this function, we're literally just going to add these. But I want to focus on the definitions for a second. These definitions will seem very intuitive and almost meaningless, and I'll explain why they actually have meaning once we write them. But the definition of f plus g of x is you take one function, f of x, you take another function, g of x, and you add them. This almost looks like a distributive property, except there is no multiplication going on. What this is saying is I'm going to make a new function. Its name is f plus g, and its name tells you how to build it. To make the function f plus g of x, you take 2 previously existing functions, f of x and g of x, and add them. So 2 functions combine and make one function whose name is f plus g. Similarly, f minus g of x is f of x minus g of x. You make a new function by subtracting 2 old functions. F times g of x is f of x times g of x. So you make a new function whose name is f times g by multiplying 2 previously existing functions. And f divided by g of x is f of x divided by g of x, written as a fraction. And again, the only difference between the left sides and the right sides, the left sides of these definitions are single functions with longer names, which tell you how to build them. And the right side is how you take 2 functions and combine them to make the new function. But don't overthink it. Just do what it's asking you to do. For example, if I want to find f plus g of x, I'm going to add these 2 functions together. I'm going to take the x plus 1, and I'm going to take the x squared minus 9. Now for this one, the parentheses are more window dressing than anything. That won't be the case in a couple of them following. Plus, there's really nothing to distribute. I guess you could argue, I'm going to distribute the plus, but it's a plus 1. Why are you wasting time multiplying by 1? So for addition, you can just do what you think you should do, which is combine like terms. The only x squared term is right there. The only x term is here. It's a positive x, so plus x. We do have 2 constant terms that we can combine. Plus 1 and minus 9 is minus 8. And let's go ahead and find its domain. Because after all, your homework's going to ask you to do it too. So, what do you think the domain of this function is? Oh, let me say that a little more specifically. What do you think the domain of this polynomial function is? It's all real numbers. No denominators, no square roots, no problems. Every number works. Every number can go into the function and answer, both real and defined. So how do we find the difference of two functions? Same way, but be careful. If we're going to find f minus g of x, we need to take the first function, which is x plus 1, and subtract from it the second function, which is x squared minus 9. And in this setup, one of the parentheses is necessary, and the other one is more window dressing. Do you know which one's necessary? This one. And do you know why? It has a subtraction in front of it. I've said it before, but if you ever see a subtraction or a minus in front of a parentheses, and the parentheses has multiple terms, you essentially distribute the negative. Nothing happens to the first parentheses because there's nothing in front of it. X plus 1, distribute the negative, and we get negative x squared and positive 9. And now when we combine like terms, the only x squared term is the negative x squared. The only x term is the positive x. And when we combine the constants, positive 1 and positive 9 is positive 10. So we got a different function. We should have. We did a different operation. Oh, guess what this guy's domain is? Well, it's still a polynomial. So its domain is still negative infinity to infinity. Okay, let's multiply. All right, x plus 1 times x squared minus 9. In this case, both parentheses are necessary. Now, one thing that I'm not sure about in the homework, so you can check this out, is whether or not it's going to require you to multiply this out. And the reason I say that is there are some examples, such as the one I'll show you in the next video, where you can't multiply it out. You just set it up and go, there it is. But let's go ahead and FOIL this out. Let's see, first is x times x, which is, first is x times x squared, which is x cubed. I'm going to do the inside next because it'll give me the next highest power. Positive 1 times x squared is positive x squared. The outer is x times negative 9, which is negative 9x. And the inner is positive 1 times negative 9, which is negative 9. And by the way, had you actually FOILed it in the FOIL order, these two would have been switched and the answer is still correct. Look, it's another polynomial. Look, its domain is still everything. Now, you might be thinking, I get it, the domain on the first one is going to be the domain for the second one, which is going to be the domain for the third one, which is not necessarily the domain of the fourth one. Why? We're about to create a fraction where there wasn't one. So we're going to create a denominator that we have to be on the lookout for when finding the domain. So, how do you divide two functions? This one's easy. You put the top one on top, and the bottom one on the bottom. Now, there could be something you could do here. So I'm just going to put a comment down here that you should try to reduce. That usually means by factoring. I know it would be tempting to cancel the x's, but I've beaten that drum many times in previous videos. In a fraction, you cannot cancel parts of addition or subtraction problems. You can only cancel parts of multiplication problems. This x, part of an addition problem. This x squared, part of a subtraction problem. Neither one eligible for being canceled. Now, there is the possibility that there could be some factoring and canceling. The numerator won't factor, but you may recognize the denominator as the difference of squares. So it would factor into x plus 3 and x minus 3. But none of the factors on the bottom match the only factor on the top, so nothing cancels. That means the factoring wasn't necessary. That's okay. So what's the domain? All real numbers? No. This has a denominator. We must avoid the denominator equaling 0. So what two numbers make this equal to 0? It should be fairly obvious. It's 3 and negative 3, which is fairly obvious over here as well. So our domain is everything except 3 and negative 3. So negative infinity to negative 3, the first number we would have to skip. I feel like we've done this already. We did in the previous video. Union, parentheses, negative 3, comma 3, close parentheses, union, parentheses, 3, comma infinity, close parentheses. So to create a new function by combining two previous functions using addition, subtraction, multiplication, and division really isn't bringing up anything that we haven't seen already, at least not yet. We just have to find their domains as well, and I promise you that the first three domains will always match, but the fourth one may have some exclusions due to the presence of a new denominator.